1.3
Common factors of a polynomial. We are going to be factoring polynomials in a whole bunch of different ways. And so far, we know what greatest common factors are, so we'll be employing that. And that will always be our first go-to when we're tasked with factoring something. Always check for a common factor. Now, individual terms of a polynomial are distinct because they are separated through addition and subtraction. So in a case like this, we know this has two terms because of this plus sign. We have a term that says 6x squared, a term that says 15x. Those are our terms there. And when we're searching for a GCF, we're going to look for a factor that is common to every term in the polynomial. We're going to dive straight into some examples where we're going to find the GCF of a set of monomials and then use it to factor the given polynomial.
All right, so looking at this first question here, our polynomial has two terms, right? Like Mr. A said, they're separated by that either addition or subtraction sign. In this case, we have addition going on. The first term is 6x squared, and the second term is 15x. We have to find the greatest common factor of each of those two terms, and then we will factor it out. So for starters, let's just start by listing some of the factors of 6, and then all of the factors of 15 to find a greatest factor between those two numbers. Well, 6, I know the factors are 1 and 6, but also 2 and 3. Those are all of the factors of 6. For 15, the factors of 15 are 1 and 15, and 3 and 5. Okay? The greatest common factor between, oh, I don't like that yellow, between the two numbers themselves would be that 3. So 3 is the greatest common factor between 6 and 15. But we don't just have 6 and we don't just have 15. We have 6x squared and 15x. So we also have to keep in mind those variables as well. So not only do they have a 3 in common, they both have at least one x. So in this case, the GCF of my two terms would be 3x because I could evenly take out a 3x out of both of those two terms. Now, when we're factoring a polynomial, what we're going to do, like Mr. A said, was that we're always going to pull out that GCF first. So if I have 6x squared plus 15x, what I'm going to do is I'm going to pull out that GCF. And what I mean by pull out is I am going to divide that out of each of those terms. So if I am dividing 3x, I'm pulling that 3x out of my 6x squared. I would get 6x squared divided by 3x. That reduces to give me 2x, right? And I could double check that by saying, okay, well, does 3x times 2x give me 6x squared? And yes, in fact, that does. And I'm going to move this, shrink it down, and I don't know, maybe put it off to the side. I have to do that as well for my second term, so I'm going to divide out a 3x from my 15x. And when I do so, I have 15x divided by 3x, which ends up leaving me with 5. And so I end up with plus 5 here. And again, I'm going to shrink that, just move it to the side. So something to keep in mind is that when I pull out a GCF, I should have the same number of terms inside my bracket as what I originally started with. So here, in my original polynomial, I have my 6x squared and a 15x. Once I pull out that GCF, I should end up with the same number of terms in my bracket. Okay? If I am ending up with less or more, check again because something must have gone wrong. Fun little tidbit here. just to make sure that I'm 100% correct, if I wanted to check my answer, I could go ahead and verify that by redistributing that 3x back to my 2x plus 5. And so just for funsies here, I'm going to do a little check. And I'm going to distribute that back and see what happens. When I go ahead and distribute my 3x to my 2x, that's 3x times 2x, which gives me 6x squared. And when I distribute it to my 5, I get 3x times 5, which is plus 15x. And this answer, when I check, should end up being the exact same thing that I started off with, which it is. And that's it for the first example. So our final answer was this guy here.
Nice. Let's try the next one. We've got a few terms there. There's a 4, a 16y, and an 8y squared. Looking at what they have in common in terms of variables, there's nothing, because sure, two of these terms have a y, but this one doesn't. So we'll just look at the numerical component, the coefficients. 4, 16, and 8. The greatest fact that they have in common is 4. So that is our GCF. And we are going to factor that out. You're right, I could change colors like so. So 4 minus 16y plus 8y squared is going to be equal to 4 being multiplied by something. And what is that something? We'll divide all the terms by our GCF. So 4 divided by 4 is 1. Negative 16y divided by 4 gives us negative 4y. And finally, 8y squared divided by 4 will give us 2y squared. If we want to double check, we can redistribute. So that's up to you if you want to have that involved. But that's how you can verify. Note that number of terms again. So we had 3 in the original, 1, 2, 3. And our final piece inside the brackets also has 1, 2, 3. And in addition, there's a very common error that we see here, and that's in factoring where the GCF in one of these terms is the same. Note that we are dividing in all cases, and 4 divided by 4 is 1. Sometimes we see people decide that they cancel, 4 cancels 4, and then they don't write a 1 there at all. That 1 has to be there. The number of terms has to be matching between the original and the factored form.
All right, if you did not already pause the video and try the next example on your own, please pause that now, give this a go, and then come on back once you're done. Oh, hey, look, it looks like you're done. So for this next example, we have 2 terms in our polynomial. We have 14x squared and we have 35. If we're looking at our variables, these 2 terms do not have any variables in common because this guy has 2 x's and this guy has got none. So we'll just be looking at the coefficients of those 2 terms to see what they have in common. Between 14 and 35, the greatest common factor, our GCF, is actually going to be 7. Alrighty, so now that we have our GCF, we can actually factor out that GCF from our original polynomial. So when we factor out that GCF, remember that we're dividing each term by that GCF. What color do I want? This one. So if I take 14x squared and I divide it by 7, I end up with 2x squared. And same, if I take 35 and divide it by 7, then I end up with plus 5. And again, you can double check to verify your answer, but it's not always necessary.
We're going to go through a few more examples, and in these examples, we're going to go a bit more quickly. We're not going to formally state the GCF. We won't have all the terms laid out individually first. The task is just going to straight up be to factor. We're going to factor each of these expressions here. We do still have to identify the GCF, even if we don't state the GCF equals something. We're still going to use it as it's pulled out and it's one of the factors. So 4x cubed plus 4x squared plus 8x is equal to something. So the GCF here for 4, 4, and 8, that'd be 4. And the GCF between x cubed, x squared, and x is just x. That's the most we can divide every single one of these terms by. And then we'll have 3 terms in the brackets. 4x cubed divided by 4x will leave us just with x squared. 4x squared divided by 4x will leave us with just x. And 8x divided by 4x will leave us with just 2. Just note the notation. I'm not just ignoring this equal sign and putting this next stuff on the next line. I am putting this equal sign here to say that it is equal to the line above it. So from a notation standpoint, that is very necessary. That there has to be a connection between the original expression and your result.
And it's even more important because if not, that's actually a communication error.
Oof.
Yeah, so be careful. Just something to keep in mind, if at any point during this video you feel like you kind of got the idea, please pause it, try those next examples on your own, and then play the video when you feel like you want to check those answers. Alrighty, so next example here, I'm starting off my next line, so I do need that equal sign in place. I am looking at all my coefficients. Between 2, 8, and 2, my GCF is just 2. Between all of my x's, here I have 4 of them, here I have 5 of them, here I have 2 of them. They all have at least 2 x's, so my GCF would be x squared. Between my y values, I have 1y, I have 3 y's, I have 1y, so my GCF in terms of my y variable would just be y. Okay, so you can break it down by looking at numbers first, then your variables individually. And now if I look at my first term and I have 2x to the power of 4 times y, and I'm dividing out my GCF, I'm dividing out 2x squared y, I am only left with x squared. For my second term, when I'm dividing out my GCF, I am left with 4x to the 3 y squared. And for my last term, I still have this negative here, right? Because I'm not having a negative GCF. And so I'll have a negative. And I am left with 1 because when I divide this last term by the GCF, note that they are identical. So when I divide them by each other, I'm only going to be left with a 1.
Oh, right, I'm awake. Here I go. All right, got some x's that are common here, got some y's that are common, got some z's that are common. Maybe I can factor out some x's and some y's and some z's. False. I cannot. If I'm extracting a term as a GCF, it has to be part of every single one of those terms. So I can't take out x because, sure, it occurs in the first and second term, but it's not in the third term. So x isn't going to be taken out as a GCF. Neither is y for the same reason, and same with z. The most I can possibly factor out of this is 7. What does that leave me with? Well, 7xy divided by 7 is just xy. 7xz divided by 7 is just 7z. And 7yz divided by 7 is just yz. What a speedster.
Alrighty, this next one. When we are looking at pulling out a GCF, again, since we are starting on that next line, and we are indicating that the two lines will be equal, we need to make sure we have our equal sign. Now, between our coefficients, 27, negative 18, and negative 36, our greatest common factor between all three of those terms would be a 9. Looking at our first variable, r, we have 2 here, we have 3 here, and we have 1 here, which means we could say that each term has at least 1r, so we will have 9r so far. And then, looking at our s variable, this one's got 2, this one's got 2, this one's got 2. Whoa, they all got 2. So when we're determining our GCF, it will have s squared involved because each term has at least 2 s's. Beauty. Now, when we are pulling out or dividing out our GCF from our first term, 27 divided by 9 is 3. R squared divided by r is r, and s squared divided by s squared is 1. Next, 18 divided by 9 is 2. R cubed divided by r is r squared. S squared divided by s squared is 1. Lastly, 36 divided by 9 is 4. R divided by r is 1. S squared divided by s squared is 1. So we just end up with such.
Just one example left for our entertainment today. And holy moly, this thing looks like a doozy. There is so much going on. Honestly, I feel a little intimidated. Just kidding. I've got this. I've got this, right?
You've got this. You got this. You got this. Yeah. No, you've got it.
I got this. I got this. I've got my favorite purple on screen. We're ready to go. So it looks like a real behemoth, but we take things piece by piece, as always. So we're starting with just these coefficients, wondering what they have in common. Personally, all I see is a 3. And then we can look at the A's. We got 3, 4, 3, and 5. So we're limited by the 3. Same with the B's. We've got 5, 1, 2, and 3. So just a single B. Bzz, bzz, bzz. And C's, there's 2, 4, 2, and 5. So 2 it is. There's our GCF. And then we start extracting all the things. I'm just going to move this over a smudge so I can keep things kind of underneath their original terms. Like so. So this first term, 81 divided by 3, will give us 27. A cubed divided by a cubed, that's all gone. B to the 5 divided by b is b to the 4. And c squared divided by c squared is just 1, so that's done. Next term, plus 27 divided by 3 gives us 9. A to the 4 divided by a cubed is just a. B divided by b is just a 1. Bye-bye b. And c to the 4 divided by c squared is c squared. Next up, a minus sign. Notice that, matchy-matchness. 24 divided by 3 will give us a rock-solid 8. A cubed over a cubed is just a 1. Bye-bye a cubed. B squared over b is b. C squared divided by c squared is just a 1. That's all gone too. And the last term, 9 divided by 3 gives us 3. A to the 5 divided by a cubed is a squared. B cubed divided by b. I've drawn a better b in my life. There we go. This is b squared. And c to the 5 divided by c squared is c cubed. So it looked like a real monster. And maybe it was, but we beat it anyways. The sword of mathematical truth is always on our side.
Anywho,
Yeah.
That's it for today. There's some practice at the bottom for you to check out. And keep in mind that we will be having a quiz that covers 1.1 to 1.3 coming up shortly. So that's all. Yeah, that's it for today.
Yeah.
Adios, muchachos.
Bye.